Hi, so welcome. Today we're going to implement multi-scale CNN network with Keras. So what is multi-scale CNN network? We're going to stack two different CNN architecture. It can be same or different number of convolution layer with different layers. Dataset will be fed into same dataset will be fed into two same. So what is CNN network? Okay, what is multi-scale CNN network? So two different or same CNN network architecture can be stacked and uh, same dataset can be fed into it. Okay, so how it will be fed into? So what is CNN network? What is multi-scale CNN network? Let's say two different, or it can be more than two CNN architecture will be stacked into a single CNN architecture. Okay, so what is a multi-scale CNN network? So check this picture. Okay, this is a single CNN architecture with three convolution layer. It is another CNN network. Okay, what is a multi-scale neural network? So check this one, the upper layer, right? So this contains four convolution layer. It is a first CNN architecture. Below that there is a two convolution layer CNN architecture. Okay, now this is our data set. It has been fed into two these networks, and all these outputs, like outputs from the both network, will be concatenated and fed into a fully connected layer. At the dense layer it will contain classification, if it is a binary or categorical, depending on that. So thing is, it can be, here it is a two layer, like upper and below. Either you can like create a more than 2 to 3, like 5. So from the research paper I got, the input size is 1024 into like around 1024, I think so. So image size is around 1024. Its HD image has been fed into 5 different neural networks, CNN neural networks. It was tagged with 5 CNN neural networks. Uh, Around each layer contains around 4 CNN, I mean 4 convolution layers. Okay, but from the starting it was max pooled. Initially it has been max pooled by 2 cross 2, 3 cross 3, 4 cross 4, and 5 cross 5. So while it's coming at the below, the input image size has been reduced. Okay, here we're going to implement only two layers. Okay, this is the main model, this is the second model below that. So the main model contains two convolution layer and max pool. At the last it will be flattened. The second layer also will be flattened. Okay, the output from these two neural networks will be concatenated, so that we need a flattened data from both these. Okay, so let's go into the multi-scale model. So this is the upper layer. So this main model is this layer, the lower model is this one. Okay, so these two are a separate model, it's not joined together. I mean, not end to end, it's like up and below. So it contains 4 convolution layer. Initially check here, there will be no max pool, but at the lower model I have introduced a max pool. Okay, let's say here I'm introducing the image 512 into 512. Here it will be reduced by 3 cross 3. So if I'm giving the same size also, it doesn't matter, the model is gonna learn. But here I'm reducing and I'm max pooling 3 cross 3 and I'm providing to the network. Okay, so after declaring the main model and lower model, so if you wanna declare a lower model 2, I mean the third layer, you can just change the lower model, just change to 2, introduce a new lower model 3, create a CNN network and compile it here. So these two model will be merged. The output from the main model and lower model should be concatenated. Okay, so Keras has a function concatenate. So main model dot output, lower model dot output. So if we have another model, let's say lower underscore model 2 dot output. Okay, so here I'm having only two layer. So these two models will be merged, and it will be the data, I mean the neurons information will be flown through again 3 dense layer. Okay, so the model is learning more, right? It's learning through so the model here, it's a multi-scale, it's learning more data from the same image. So I am passing through the 3 dense layers with a kernel size of L2 with 0.01. So here the model is learning more. Okay, so that particular reason I am passing the information through the 3 fully connected layers with L2 penalty. So after, so here the number of classes is 4. Okay, my data contains 4 classes, so here I'm giving 4. If it is 2 or 3, it depending upon number of classes. So once the model is completed, it's a merge model is completed, now we're gonna compile all the thing into a final model. Okay, so input will be main model dot input, lower model one dot input. Here again you should give, if you are given the lower model underscore 2 dot output, here you should give lower model 2 dot input. Okay, so here also you should change. Then I'm gonna compile the model. Okay, so wait, let me compile the model. Okay guys, so I got an error. So it's layer feature has no inbound nodes. So the thing is, while giving max full, I forgot to give the input shape for this particular. Okay, so once I compile, so the model has been compiled. Final underscore model dot summary. So okay, so both this model has been compiled. It will be merged. So at last we'll have 4 classes. Okay, so this is my data set. So I'm using an image data generator to load. So thing is, till this it's gonna be same. So training directory, image data generator, some augmentation, image data generator for test and input. So okay, so how to load the data? We're gonna use image data generator, same stuff. We're gonna load the data from the directory, but you have to write a simple function code. Okay, so for the training I'm gonna use a little data augmentation. For the test that's gonna be no data augmentation. Okay, the function. Okay, so flow from the directory, same stuff, path, target size, batch, seed and subset. Thing is, shuffle you should give always false. Okay, let me tell you why. So if you give true for CNN1, I mean the main model, it may go a different image, and for the lower model it might go a different image. So we gonna give false, so both neural network. Okay, let me tell you why you're giving false. Okay, let me tell you why you're giving false to the shuffle. If you give true, different image will be passed to the different neural networks. Here we need the same image for the first CNN model and the second CNN model. That's the reason we're giving false. Then write a while code. So both these data will be iterated. Yield function, it will take the images and the label. Let's say here you're gonna created a 3 CNN network. Okay, x3i0. So 3 times the images will be taken and with their label. Okay, so 0 it denotes the images and 1 it denotes the image. Sorry, label. Here, so input generator and test generator. Using this function, you're gonna load the data. Generator, you're gonna use the input, the data gen we used. Here you have to give 2 times the directory. So using the function we created, we're gonna load the data. So according to the input variables, just create the function, load all the value. So training and validation. Then we're gonna fit the, we're gonna train the model. Same stuff. Input generator, what is the training data, steps per epochs, validation data. Here also you give false. So when you're training and validation will be same, the images will not go. See here, So initially at the first epoch I'm getting around 0.92, even though I've introduced dropout L2. So even sometimes I increase the dropout to 0.8, so still it's getting overfitting. So that might be a problem in the image what I use. So still try this. So for 3 neural networks or more than 3, so create another function. I mean in the function just change to 3. So it's gonna be directory 3. Here also add dir 3 here, comma x 3i 0. So here also add directory 3 is equal to train here 3. Same you do for the test. Okay, train the model, see what is accuracy you are getting. Most probably whatever the data set I tried, it was with bacteria. So always with 10 or 15 epochs, it was reaching around 95, whatever the optimal solution I give. Play with the learning rate and different optimizer, and play with the dense layers. Try to change the max pool. Okay, so initially you are giving the first layer the whole size like 512 into 512. Here I am giving 3 cross 3, the max pool will reduce the image. So if I getting the overfitting more, try to increase the max pool max pool value. Okay, this is how to implement a multi-scale CNN network with Keras. Thank you.